The Hubble represents mankind's persevering through want to grasp the universe, with its essential mission to open the mysteries of the universe through amazing symbolism and spearheading logical revelations. Sent off to rise above Earth's environmental limitations for divine perceptions, the point of the Hubble was to accomplish unrivaled lucidity and accuracy in survey far-off vast elements. Astronomers came up with the idea for a space-based telescope to avoid atmospheric distortion because the Earth's atmosphere distorted and obscured the light received by terrestrial telescopes. The outcome of the Hubble Space Telescope based upon past space tries and exploration, for example, the Circling Cosmic Observatory missions and the Apollo moon arrivals, featuring the advantages of noticing space from past Earth's climate. In addition, mechanical headways, outstandingly in optics and space investigation, were essential advancements. The Hubble was able to be outfitted with high-resolution cameras, spectrographs, and other specialized tools for capturing and analyzing space light with extraordinary detail thanks to mirror technology and precision instruments designed for the rigors of space. Situated in a low Earth circle at an elevation of roughly 340 miles, 550 kilometers, the Hubble has given notable symbolism and huge revelations across a wide range of cosmic fields. For instance, in 1995, the Hubble Space Telescope stared into what appeared to be a void for 10 days. However, it found thousands of galaxies in a relatively small portion of the sky, demonstrating the vastness and variety of galaxies. When it took the Pillars of Creation picture in the Eagle Nebula in 1995, it showed enormous columns of gas and dust where new stars were being formed. Somewhere in the range of 2003 and 2004, the Hubble created a considerably more nitty-gritty perspective on the universe through the ultra-profound field picture, uncovering systems that shaped soon after the enormous detonation. It has looked at the atmospheres of exoplanets and found evidence of water and organic compounds that point to life. Additionally, the Hubble observed the development of the closest supernova ever observed, SN 1987A, providing novel insights into the star's life cycle. Most importantly, the Hubble Space Telescope has been instrumental in approving and refining essential cosmological hypotheses, like the huge explosion in the universe's development. By noticing far-off universes and enormous microwave foundation radiation, the Hubble Space Telescope has conveyed strong proof supporting the theory of how things came to be through its perception of the redshift peculiarity, where light from far-off systems is extended, demonstrating their speed of downturn. This crucial data supports the hypothesis that the universe is expanding as predicted by showing that galaxies further away are retreating at a faster rate. Moreover, Hubble's discoveries have been essential in calibrating the gauge of the universe's development rate, typified in the Hubble steady, a proportion of the universe's extension speed comparative with the distance of worlds from us. Not set in stone by cosmologist Edwin Hubble during the 1920s, the Hubble Space Telescope has refined this consistent through ensuing perceptions. Be that as it may, changing estimation procedures have yielded contrasting qualities for the consistent, featuring an area of dynamic logical request with no conclusive goal yet. In addition to broadening our understanding of the cosmos, these groundbreaking observations and a great number of others have produced stunning images that have captivated the public's imagination and enhanced our comprehension of space phenomena.
For unseen physics
the James Webb Space Telescope, JWST, was created as a result of NASA's desire to launch a successor that could surpass Hubble's achievements. NASA's logical missions have wandered past Hubble, investigating the planets, moons, and external ranges of our planetary group through projects like the Mars Meanderer, Explorer missions, and other heavenly investigations. These undertakings have leveled up NASA's space investigation abilities, powering development and innovative advancement essential to the JWST. The send-off of the JWST remains as a huge achievement for the American Space Organization, driving us closer to unwinding the universe's secrets, starting points, and extreme fate. The JWST, in contrast to its predecessor, is designed to observe light at longer wavelengths, from visible to mid-infrared, giving it a wider and clearer view of the universe. As of late, the JWST disclosed a historic finding that has captivated the two researchers and people in general, the discovery of a wonderful light group from a planet 7 trillion miles from Earth. Otherworldly examination proposes the planet, known as WSP-96b, might actually hold on to extraterrestrial life. This revelation challenges customary cosmic perspectives, igniting fervor and interest in the chance of outsider life past our nearby planet group. The discovery has had a profound impact on the scientific community, prompting us to reconsider our comprehension of the cosmos and the possibility of life elsewhere. To get a handle on the extent of this revelation, think about the shocking distance of 7 trillion miles, or approximately 1,140 light-years, from Earth. This distance features the JWST's uncommon ability to test the profundities of room, catching subtleties according to an extraordinary viewpoint. It pushes the limits of our observational capacities and changes our cognizance of the universe, highlighting the telescope's part in growing our perspective on the universe a long ways past our nearby grandiose area. The JWST's main goal is to be an innovative astronomical observatory that can do more than the Hubble Space Telescope can. The JWST was unpredictably intended to infiltrate inestimable residue mists and give more clear perceptions of far-off galactic articles, uncovering recently clouded enormous occasions and offering unmatched bits of knowledge into the beginnings and development of the universe. It is furnished with creative highlights and cutting-edge innovations that mark it as a mechanical miracle. It has an enormous primary mirror with 18 gold-coated beryllium segments measuring 6.5 meters in diameter. With cutting-edge infrared imaging capacities, including the close-to-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, the JWST catches a large number of infrared frequencies, permitting specialists to concentrate on the development of stars, worlds, and planetary frameworks with remarkable clearness. In addition, the JWST operates at a frigid -266°C thanks to a complex 5-layer sunshield made of captain and other advanced materials that shields its delicate instruments from the sun's heat and light. The discovery has had a profound impact on the scientific community, prompting us to reconsider our comprehension of the cosmos and the possibility of life elsewhere. To get a handle on the extent of this revelation, think about the shocking distance of 7 trillion miles, or approximately 1,140 light-years, from Earth. This distance features the JWST's uncommon ability to test the profundities of room, catching subtleties according to an extraordinary viewpoint. It pushes the limits of our observational capacities and changes our cognizance of the universe, highlighting the telescope's part in growing our perspective on the universe a long ways past our nearby grandiose area. The JWST's main goal is to be an innovative astronomical observatory that can do more than the Hubble Space Telescope can. The JWST was unpredictably intended to infiltrate inestimable residue mists and give more clear perceptions of far-off galactic articles, uncovering recently clouded enormous occasions and offering unmatched bits of knowledge into the beginnings and development of the universe. It is furnished with creative highlights and cutting-edge innovations that mark it as a mechanical miracle. It has an enormous primary mirror with 18 gold-coated beryllium segments measuring 6.5 meters in diameter. With cutting-edge infrared imaging capacities, including the close-to-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, the JWST catches a large number of infrared frequencies, permitting specialists to concentrate on the development of stars, worlds, and planetary frameworks with remarkable clearness. In addition, the JWST operates at a frigid -266°C thanks to a complex 5-layer sunshield made of captain and other advanced materials that shields its delicate instruments from the sun's heat and light. Situated at the second Lagrange point, L2, around 1.5 million kilometers from Earth, it circles the Sun rather than the Earth. A stable, clear view of the universe, unaffected by Earth's atmospheric and thermal disturbances, is provided by this singular location. The JWST surpasses previous space observatories in terms of its groundbreaking technology and instruments, revolutionizing our capacity to investigate the cosmos. An essential goal is to look at the environments of exoplanets for indications of livability, including the presence of water and methane, which could propose conditions great forever. It observes the light from the first galaxies, stars, and cosmic structures that emerged billions of years ago while simultaneously capturing radiation from incredible distances. Understanding the formation and development of stars, the assembly of galaxies throughout cosmic history, and the universe's origins and evolution require these observations. The JWST mission rises above the investigation of our nearby planet group, planning to uncover and understand the tremendous, different, and growing grandiose web that encompasses us. The JWST has captured detailed images of Stephan's Quintet, a group of 5 galaxies located approximately 280 million light-years away, one of its numerous significant discoveries. The remarkable discoveries about far-off galaxies and nebulae made by the James Webb Space Telescope, JWST, which was launched on December 25, 2021, from the Guyana Space Center, have significantly improved our comprehension of the universe. The observation of the SMACS 0723 galaxy cluster, which is about 5 billion light-years away and provides insights into galaxy formation and evolution in the early universe, is one example of this kind of discovery. One more wonderful disclosure from the JWST is its nitty-gritty symbolism of the Carina Cloud, a star-shaping locale around 7,600 light-years away, exhibiting the perplexing cycles engaged with the introduction of new stars. Scientists are now able to investigate the genesis and evolution of stars within this cosmic nursery thanks to the unprecedented clarity provided by the telescope's observations. As a result of the JWST's examination of the Southern Ring Nebula, we now know more about the nebula's structure and dynamics thanks to the discovery of a second star in its binary system. A one-of-a-kind opportunity exists to investigate stellar interactions and the final stages of stellar evolution in this nebula, which is approximately 2,500 light-years away. The James Webb Space Telescope, also known as JWST, is currently at the forefront of astronomical research and is poised to decipher the universe's mysteries with an unprecedented level of clarity and precision. This cutting-edge observatory, which will be launched on December 25, 2021, from the Guyana Space Center, represents a significant advancement in space observation. The James E. White Space Telescope, JWST, is a joint venture between NASA, the European Space Agency,